Welcome. So today we're going to be doing preparation of salts. Hopefully we will be done with this topic in this video itself. At the end of this video I have 2 past paper questions which I believe will help ensure that the concept is clear. Again, this topic is very important because there have been questions worth of 10 marks that are solely related to preparation of salts, so make sure that you know this topic really well. So we know that salt is a neutral compound. It's essentially a compound in which the hydrogen ion is being replaced by a metal ion. For example, you have hydrochloric acid, and if you add potassium hydroxide to it, you get the salt potassium chloride. So the hydrochloric acid is being replaced by the potassium ion, giving you the salt, the compound potassium chloride. And of course you also have water. So neutral compound, also remember that it's number 7 on the pH scale. So there are different ways to obtain a salt. The 3 ways that we will be doing are the excess method, titration, and precipitation. So, number 1, the excess method is basically between an insoluble base and an acid. Insoluble in water, of course. Not in the acid itself, because obviously then the reaction won't occur or it won't work out. It can be an insoluble base, it can be a metal and acid, and it can be a carbonate and acid. So the excess method is between insoluble base and acid, or it can be between a metal and acid, or it can be between a carbonate and acid. I will use the example of copper oxide and hydrosulfuric acid for you guys to understand this method. So first of all, you're going to add excess copper oxide into hydrosulfuric acid. Now they're going to ask you why excess, and you need to, and this is a very common question, so they will ask you, why are you using excess copper to oxide? Excess meaning more than the adequate amount. You're using more than the adequate meaning sufficient. So basically, essentially, they're asking you, why are you using more than what is required or more than what is needed? And the reason behind that is to ensure that all the acid is used up. This is very important. Make sure you know this. Why are we using excess copper to oxide? Why are we using excess insoluble base or excess metal or excess carbonate? It's to ensure that all the acid is used up. Now, the acid is usually warmed up. It's a warm solution, and they might ask you why is it warm, and that is to increase the rate of reaction. So your first step is that you are adding excess copper to copper oxide, to warm hydrosulfuric acid, or to warm acid. The second step is you're going to stir using a stirring rod, obviously, or a glass rod. Make sure you know the apparatus that you use throughout your IGCSE syllabus. Make sure you know the basic ones, the stirring rod, the conical flasks, and the pipette and the burette that we will see in 2 minutes, and the Bunsen burner. How are you going to warm this acid? You're going to use the Bunsen burner. The evaporating dish. So make sure you go through the apparatus before you go to your exam, especially before the ATP. Now, stir using the stirring rod, and you keep stirring until the excess stops disappearing. So when it stops disappearing, that is your indication that the reaction has occurred and it's finished and the acid is used up. That's as far as it can go. Now after that, what you need to do, you need to filter out the excess. What do I mean by that? Basically, when you add, so here's a hydrosulfuric acid, and you're adding a lot of copper 2 oxide, and you're adding more than the needed amount. Well, since you're adding more than the needed amount, the acid is used up, and there is still a little bit of copper oxide left behind, because you added more than what was necessary. So the necessary amount did its job, the acid is used up, and then you have a little bit left behind. So you need to filter that out using the filter funnel and filter paper. That will leave you with the with a solution of copper sulfate, which is what we are trying to form using copper oxide and hydrosulfuric acid. So now you have this solution, you have this filtrate, and you will transfer the filtrate to an evaporating dish. So this is transferred to an evaporating dish. And since it will start evaporating the excess solution, the excess liquid, what will happen that this will start to crystallize, and crystallization will occur. They will basically form crystals, and that is your salt. You could also add a little bit of heat over here, to increase the rate of the reaction. But basically, essentially what happens is that crystallization occurs and you have your salt crystals, you have copper sulfate as a salt ready to go. If you do provide heat, and this will also, I will repeat this in the titration method, do ensure that you do not provide too much heat, because what will happen then, you will get anhydrous salt. What is anhydrous? Anhydrous is just a fancy way of saying dehydrated. Basically, you will not get pretty hydrated crystals, you will get powdered salt, which you don't want. So ensure, they might ask you, why would you only heat for a small period of time, or why would you not give it too much heat? And the reason is because you do not want anhydrous salt, you do not want powdered version of the salt. Now let's move on to titration. These are the past paper questions that we will come back to. Okay, so titration. Now, the above excess method was between insoluble bases and the acid. The difference between that one and this and titration is that it's between soluble base and acid. And the excess method, your reactant, your insoluble, whatever, is in solid form, obviously. And over here, you're going to have your base and acid both in aqueous form. You need to know the apparatus here. It's very important. You have the pipette, the burette, the conical flask, and the stirring rod. Actually, no stirring rod for this one. You will also require the indicator. So, essentially what you have is a conical flask. I'm going to try and draw a better conical flask. And over here, you have your burette. Do not mind my drawing. It's not the best thing out there. You can easily find a picture of this on Google. You need a whole clamp stand to hold your burette. Okay. So over here, you will have your alkali. I'm going to use the example of potassium hydroxide and hydrochloric acid to explain this method. So over here you have your potassium hydroxide and you have added your alkali by using the pipette. And for your ATP, they do ask sometimes in different experiments though, why are you using a pipette over a burette? And that's because a pipette is more accurate than the burette. Or they might ask you, why would you use a pipette? And that's because it has great accuracy, so very accurate. So over here you have your potassium hydroxide, for example, and in the solution you also have an indicator. Usually it's litmus solution. However, they added the recent indicator thiamulfathiolin. However, I do not think that it will be used for this particular experiment, but you should know that the thiamulfathiolin is colorless in acid and it's blue in alkali or base. I'm going to be using litmus over here. You're going to have your litmus solution indicator, which is currently blue because the copper hydroxide solution is basic and therefore it's going to be blue right now. Now what you're going to do is you're going to have the acid filled in the burette to a certain volume, whatever volume you are comfortable with. So you're going to note the starting volume of the burette. Then you're going to, there's this clamp over here that you can rotate. So you're going to add the acid drop by drop. You will not add it all in one go because what you're essentially trying to do here, you're trying to get the exact volume at which the litmus will change its color because the solution has officially become neutral, therefore it has officially formed the aqueous salt. So you need that volume and you need to stop at the point when you have formed your salt because you do not want the acidic substance, you want the neutral substance, you want your salt. So you're going to be careful and you're going to do it drop by drop. Note the volume of the acid when the litmus solution changes color. So the second that it becomes purple, you know, okay, the salt has now been formed. The salt is produced. Potassium hydroxide plus hydrochloric acid has now formed potassium chloride. Now you note the volume of the acid because you cannot use this solution as your final product because it contains the litmus indicator. You cannot have the indicator in your salt. So what you're going to do is you know that the final volume minus the initial volume is the volume of acid needed to form the salt. So now that you know, okay, I need this much of the acid added to this much of my base, you will repeat the experiment with the known volume forming your salt without anything else in it. You will form your pure salt, which is what you want. After that, the solution that you will get here, the aqueous solution of potassium chloride, you will heat it for crystallization. Again, make sure to not overheat it because you do not want anhydrous salts. You want hydrated salts. You do not want the powdered form. You want pretty crystals. Do make sure that you heat it in an evaporating basin. What that does is it makes a saturated solution, and then, as I said, that it starts to crystallize. They do ask you how you know that your salt is crystallized and it's formed, and the thing is that when you put in a glass rod into your evaporating dish and you pull out the glass rod, you will see the crystals formed on the glass rod. So that's an indication of knowing that your crystals are formed. So again, to not make sure you put this as a prevention if that's in the question, to not overheat because you do not want anhydrous salts. Now, they might ask you an alternative method, and your alternative method would be that instead of repeating the experiment, so from here is where your chain, you can have a different method. Instead of repeating the experiment, what you could do is add one second. Alternative. What you could do is add charcoal to the solution. And what charcoal does is that it absorbs the indicator. And then you can just filter out the charcoal. So it's quite common for preparation of salts to come as an experiment in your ATP. So you could go for both methods. You could say measure the final volume, get the change in volume, repeat the experiment, or you could just say add charcoal to the solution, which will absorb the indicator, and then you can filter out the charcoal, and the rest of the experiment remains the same. So that is your titration. Let's move on to precipitation. And what precipitation does is it uses two soluble reactants to form an insoluble salt. And this is by far the most simple method out of all of them. You just add two things together and you wait it to do its job. To form an insoluble salt. Basically, I'm going to take the example of lead sulfate. Oh, and very important, when I say soluble reactants, what I mean is that you need two soluble salts, which will give you your insoluble product, your insoluble salt. Okay? So let's take lead sulfate for as an example. Lead sulfate is insoluble. To form this salt, you will need two soluble salts, one with the lead as a reactant and one with sulfate as a reactant. So I'm going to choose, let's go with lead nitrate, sorry. All nitrates are soluble. At the end, after I'm finished with the precipitation reaction, I will give you guys the solubility rules so you know what is soluble, what is insoluble. All nitrates are soluble, so let's go with lead nitrate as one salt. This is soluble. Check that. That's your first salt. Sulfate, potassium sulfate, soluble easily because all sodium salts, all potassium salts are soluble. Potassium sulfate, yes. And this is also soluble. So as you can see, I have the lead in a soluble salt and I have the sulfate in a soluble salt, which will eventually give me my lead sulfate. What you're going to do is you will initially have these in solid form, usually. So you will dissolve each solution in water to get an aqueous solution. Then when you have your two solutions, what you will do, you will mix them together. And when you mix them, a precipitate forms. This precipitate is the salt that you were aiming to make. You wanted to make an insoluble salt and you got it. You get the precipitate in solid form, and then you will filter it out. And when you filter it out, you will wash it with distilled water to get rid of impurities, and you will dry it between filter papers or in an oven. So see, super simple. You have your two soluble solutions, and here I will add another beaker in which these two will go. That will, you get your precipitate. That is your salt. You will filter it out, and got a second drawing. You will filter it out, and you will wash it. You will dry it. You have your solution. You have your. Okay, I had to leave for 2 seconds, so I'm not sure where I left off, but I will just repeat myself. Two solutions, they come in together. The precipitate forms, you filter it out, you wash it, you dry it, and boom, you have your salt. So the solubility rules, so you know what is soluble and what is insoluble. This is very, very important. Know these by heart, please. You will have... No, actually, you will not have these solubility rules in in your ATP you will have the other tests. I'm not quite sure though in the 2025 papers if you will be given the solubility rules in your ATP test, but you still should know all the tests and rules by heart because you will not have the same luxury in your theory and your MCQs paper. So to start off, all sodium, potassium, and ammonium salts, yes, ammonium salts are soluble. So anything with sodium, potassium, ammonium, it's immediately soluble. All nitrates are soluble. All of them. Chlorides are usually soluble, so most chlorides are soluble, except silver and lead. So, except silver and lead, chlorides are soluble, so you need to know silver chloride is insoluble, lead chloride is insoluble. Same thing with sulfates. They're mostly soluble with the exception of barium, calcium, and lead. Once again, very important. You need to know these exceptions because these are practically your precipitates, your precipitation reactions. So all sulfates are soluble with the exception of, with the exception of barium, calcium, and lead. Carbonates are insoluble with the exception of sodium, potassium, and ammonium. Sodium, potassium, and ammonium. Now, that makes sense because you already know that all salts with sodium, potassium, and ammonium are soluble. So, considering carbonates are insoluble, there will be the exception of those that are always soluble anyways. So, other than the ones that are usually soluble, the carbonates are insoluble. Hydroxides are also insoluble, basically the same thing as carbonate, with again the exception of the ones that are always soluble, which is sodium, potassium, and ammonium. Never mind. Ammonium, there we go. So please make sure you know these solubility rules, very, very important. Let's move on to the past paper question that I had planned. Okay. So, soluble salts can be made using base and acid. Complete the method of preparing dry crystals of the soluble salt cobalt chloride 6 water from the insoluble base of cobalt carbonate. So this is the insoluble base. We know that this is the excess method. And you will also know that because they've given you step 1, which is add an excess of cobalt carbonate to dilute hydrochloric acid. So the next step would be to stir until excess disappears. And then filter out the remaining excess. Step 3, you can transfer solution or filtrate to evaporating basin and allow crystallization and allow it to basically crystallize. And after that, you will dry the crystals between filter papers. Now, I know it might be confusing to know which step comes where, or what do I write in step 2, what do I write in step 3, but basically your last step is drying. So everything before that you write in step 2, step 3, just divide it the way you want to. You could have written stir until, you don't even have to write this actually. Usually in your IGCSE paper, they do not give this step much importance. It's greater weightage and greater importance of the step is filtering out the remaining excess. So just write all that you know before drying in step 2 and 3, and then step 4 is your drying crystals. Now this is a 10-mark question solely based on the preparation of salts. So method A uses a Barrett indicator, so that's titration. Method B is mixing 2 solutions to obtain salt by precipitation, and method C is the excess method. So for each of the following salt preparation, choose one of the methods, name any additional reagent needed, and write the complete equation. So number 1 has the soluble salt zinc sulfate from the insoluble base zinc oxide. Immediately when you see insoluble base, that is the excess method. Zinc oxide is added in excess to sulfuric acid to give you zinc sulfate. So this is method C. Remember, method C is insoluble base, metal, or carbonate. Reagent, they said additional reagent. We already have zinc oxide as 1. And to form zinc sulfate, you're going to need the sulfuric acid. So that is your reagent. And the word equation. So we know we have zinc oxide plus sulfuric acid. This is acid plus base gives salt, which they have already told us what is forming, and we should know anyways. Gives salt plus water. So those are your 3 marks. The soluble salt, potassium chloride, from the soluble base potassium hydroxide. Again, this over here is your immediate indication that we are using method A. Soluble base, method A. Insoluble base, method C, excess method. Soluble base titration, insoluble base, excess method. And over here, your indication is the insoluble salt. That is your product precipitation. So do not forget these indicators, the way to know which method. They say insoluble base, you go for the excess method. They say soluble base, you go for the titration method. And they say insoluble salt, then you go for the precipitation method. So this one is method A. And they have told us that potassium chloride is forming from the soluble base potassium hydroxide. And since we need chloride, then you're probably using the hydrochloric acid. So from the potassium chloride, we are getting the potassium from potassium hydroxide. That's check. Where are we getting the chloride form? From the hydrochloric acid. The equation. So we have HCl plus potassium hydroxide. That's giving you salt and water. There is no need for balancing over here. It's all balanced. However, in other questions, that's not usually the case. Make sure you balance your chemical equation. The insoluble salt lead iodide from the soluble salt lead nitrate. That would be method B, precipitation. Now, this is the insoluble salt precipitation, which means that we need 2 soluble salts. We already have lead nitrate, and from lead nitrate we get our lead ion. So we need a soluble salt. What? Okay, I seem to have lost the writing, but it's fine, we solved it. Okay. This is the precipitation. Oh, great. I don't know what's happening. All right. I got the lead ion from the lead nitrate. Now I need the iodide ion. Where will I get that from? For this, always go for the salts that you know are always soluble, which are the sodium, potassium, and ammonium. That is your safest bet because you know that anything with them is always soluble. So I will choose potassium iodide. Now you need the ionic equation. So we know that potassium iodide is what's forming as the product. Okay. How do you know this formula? I will just quickly tell you in case no one knows. Lead has the charge of 2 because it's in the second group. And iodide has the charge of 1 because it is in the 7th group. So 8 minus 7 is 1. This is extra information. But from groups 1 to 4, you will choose the charge as the group that it is. So if it's in group 1, then it will be number 1. Group 2, it will be 2, and so on and so forth. From groups 5 to 8, the charge of the element in this group will be the difference between 8 and the group that it is. So if it's in group 5, then your charge will be 3 because 8 minus 5. If it's in 6, then the charge will be 2 because 8 minus 6, and so on and so forth. So since this is in group 2, you will have 2. Since this is in group 7, 8 minus 7 is 1. It will cross multiply. You will get PB1. You never need to write the 1, and you get I2. Now they've already given us PB2 plus, which means that the ion that is missing in this ionic equation is I. And it's going to be a minus because it is a nonmetal. And since you have I2, to balance that, you're going to put 2I. They have specified in the marking scheme that you will not get the full marks if your thing is not balanced. So make sure you balance your equation. So I hope you guys understood this concept. If you have any questions, comment them down below. Hopefully I will most likely reply to them. And let me know if you guys have any specific requests for the next chapter you want me to cover.